Welcome to my YouTube channel. Consider subscribing. This is physical chemistry, and we are going to learn about the acid and bases. Actually, there are three uh, concepts. There are three concepts of acid and bases which are currently in use, and each has its own peculiar advantages. The three concepts are Arrhenius concept, Preston-Lowry concept, and the Lewis concept. First, let's look at Arrhenius concept. In 1884, Arrhenius proposed his concept of acid and bases. According to his concept, an acid is a compound that releases hydrogen ion in water, while a base is a compound that releases hydroxyl ion in water. For example, HCl is an Arrhenius acid, while sodium hydroxide is an Arrhenius base. There is an equation there which shows that an HCl producing hydrogen ions and sodium hydroxide producing hydroxyl ion. Okay, there are various limitations on Arrhenius concept. Arrhenius concept of acid and bases proved to be very useful in the study of chemical reaction. However, it has the following limitation. The first limitation is that free hydrogen ion and hydroxyl ion do not exist in water. The the hydrogen ion and hydroxyl ion produced by an acid and bases respectively do not exist in water in the free state. They are associated with water molecules to form a complex ion through hydrogen bonding. Thus, the hydroxyl ion form a hydronium ion. Limitation number 2 is limited to water only. Arrhenius define an acid and base as a compound producing hydrogen ion and hydroxyl ion in water only. But the truly general concept of acid and bases should be appropriate to other solvents as well. Some bases do not contain hydroxyl ions. Arrhenius base is one that produces hydroxyl in water. Yet there are compounds like ammonia, calcium oxide that are base but contain no hydroxyl ion in their original formulation. Arrhenius' model of acid and bases no doubt prove very helpful in interpreting their action. However, on account of its limitation, the Arrhenius concept needs to be modified. We are going to the second concept, and that is Prostate-Lowry concept. In 1923, Preston and J.M. Lowry independently proposed a broader concept of acid and bases. According to this theory, an acid is any molecule or ion that can donate a proton. For brevity, we can say that an acid is a proton donor, while a base is a proton acceptor. Examples of acid and bases: HCl gas and water. When I try HCl gas dissolved in water, each HCl molecule donates a proton to a water molecule, produce hydronium ion. Thus, HCl gas is a prostate acid, and water that accepts the proton and is a prostate base. HCl and ammonia. HCl gas react with ammonia to form solid ammonium chloride. HCl is a proton donor and hence proton acid, while ammonia is a proton acceptor and a proton base. Calcium oxide and water. When calcium oxide is dissolved in water, it's converted to calcium hydroxide. Here, a water molecule donates a proton to form oxide ion and is proton acid. The oxide ion accepts a proton and gives hydroxy ion, hence prostate base. Prostate-Lowry concept is superior to Arrhenius concept because much wider scope. Arrhenius concept of acid is restricted to study of substance which can release hydrogen and hydroxyl ion in water. Prostate-Lowry concept embraces all molecules and ions that can donate a proton acid and those which can accept a proton bases. The next advantage is that not limited to aqueous solution. The Prostate-Lowry model is not limited to aqueous solution, as in this case with Arrhenius model, it can be extended even to gas phase. For example, gas ammonia, a prostate base, can react with hydrogen gas, a prostate acid, to give ammonium chloride. Advantage number 3, release of hydroxyl not necessarily qualify as a base. Arrhenius base is that release hydroxyl ion in water. On the other hand, proton is a that accept a proton. Thus, liquid ammonia does not produces hydroxyl in water, but it is recognized as a base. But according to Preston Lowry, it's qualified as a base in it can accept a proton to form hydroxyl ions. Conjugate acid-base pairs. In an acid conjugate reaction, the acid gives up its proton and produces a new base. The new base that is related to the original acid is called conjugate, meaning related base. Similarly, the original base, after accepting a proton, give a new acid which is called conjugate acid. The acid and the conjugate base that are related to each other by donating and accepting a single proton are said to constitute a conjugate acid-base pairs. It may be noted that in any acid-base reaction, there are two conjugate acid-base pairs. Thus, in the above equation, two conjugate pairs are H A and A, H B and B. Here is an illustration showing the Prostate-Lowry acid-base pairs. You can see an acid and a base, the acid donating a proton and a base accepting a proton. So you can see a conjugate base and a conjugate acid. We are going to the third concept, and that is Lewis' concept of acid and bases. In early 1930s, J. N. Lewis proposed even a more general model of acids and bases. According to Lewis' theory, an acid is an electron pair acceptor. A base is an electron pair donor. Lewis picture an acid and bases is sharing electron pair provided by the base. This creates a covalent bond and a coordinate bond between the Lewis acid and Lewis base. This is an example of a Lewis acid base between hydrogen ion and ammonia. Proton ion, hydroxyl ion, or hydrogen ion is a Lewis acid as it can accept an electron pair. An ammonia molecule has an electron pair which can donate and is a Lewis base. Thus, the Lewis reaction between hydrogen ion and ammonia can be written as follows. Okay, there are some advantages in this concept of Lewis acid base Beaumont 10, and these are the advantages. All the Bronsted-Lowry acid base reactions are governed by Lewis model. It's also is so because the transfer or gain of a proton is accompanied by the loss or donation of an electron pair in both types of reaction. Number two, many reactions which do not involve transfer of a proton, e.g. Ammonia and bromine are also covered by the Lewis theory. We are coming to the conclusion of our topic. Thank you and see you in the next lesson.